says we are. Okay. All right. So good morning, everybody. Not the evening I was expecting, but you know, things happen. So, all right. Well, let's get to it. So last time, let's just kind of recap where we were on. Let me just download this and open the full screen version. Right. Last time, what we did was we were looking at how to do a conditional expression in this architecture, right? So we did basically an if then else type construction with and we just picked something sort of random. So we basically went through and said, all right, let's figure out how to tell if a number is positive, or rather if it's negative or not negative. Okay. And then based on that, do two different things. And basically, it all came down to, in the architecture, it all came down to this jump instruction. So the jump instruction is the only one that makes a decision or has the word if in it anywhere, right? So anything where you do something that's an if then kind of construction, or a something that involves an if then kind of construction, like a for loop or a while loop or something like that, right? With a for loop or a while loop, what do you have to decide at some point? You have to decide, do I keep looping or not, right? And that decision has to be done based on some sort of numerical thing, right? So you would say something like, while the number of pieces of bread is greater than 0, or while, or for, I from 1 to 20 or something, I don't know, do something. Okay, so what would you do? Well, you would start looping, and then each time you loop, you need to check, hey, am I finished or not? Do I need to continue looping or not? Okay, so does that kind of make sense? So loops will actually involve, and this may be a little bit surprising, they're going to involve 2 jump commands, not just one. We'll see why we need a second one in a moment. Okay, so let's just start writing something. Let's do something that just counts, 1 to whatever. Okay, so that's kind of a stupid program, but it'll work. We need something. Okay, so let's see. Where is, I want Adam. Okay. All right, so let me hide the sidebar so this can be a little bit bigger. And then let's make a new file. And let's call this loop 1. Okay. Okay, so first off, let's just kind of write what we want to do in sort of Python looking syntax, just so we're clear on what the program is supposed to do. So I could do something like this. Let me set a number equal to, well, actually, let me just do this. For num in range 1 to 11. Well, let me not use such a big number just for sake of example. Let me actually do this. Oops. Okay, so let's do this. Okay, so and let me just say in Python, like often we print things. Okay, we can't really print anything in this assembly architecture because there's no screen or any device like that to output to. Okay, but in this case, the sequence, or sorry, the variable that I've called num, or answer, sorry, uh, will take on a range of values as the program executes. Okay, same thing with the value of the variable num. All right, so let's start with num. What are the values that num will take on over over the execution of this program? Well, what's the first value that num will take on? 1, okay? Because I said for num in range 1 to 5, okay? What's the last value that num will take on? 4. All right, how many of you did I just nail on that one? Yeah, okay. So what's the convention here? In Python, 1 to 5 means include 1 but not include 5. And I'm sorry, that's just the way it was, right? That's how Guido von Rossum set it up, so that's what we have. Okay, so num will take on the values 1, then 2, then 3, and then 4, okay? And in this particular case, in Python, do I ever actually have to say to add 1 to num each time I run the loop? Do I have to type that instruction here in Python? No, it's built into the idea of the for loop. Okay, so actually, why don't we rewrite this and make it a little bit more explicit what we're actually doing? This is really that's really what we're doing. Oh yeah, that too. Thank you. Okay, that's really what we're doing, right? We say, okay, num starts at the value 1. While number is less than 5, we need to do something, okay? And what things do we do? Well, our answer starts at 0, and we're going to add num to each time. And then we need to increment the num by 1. Okay, now, in Python, all of that is built into the way I set up my for loop, okay? But in machine code, we have to do all of these things ourselves, okay? So really, we're going to write the second thing there. All right, now there's a couple of things that we're going to have to figure out. Setting answer to 0 or num to 1 or doing the 2 additions there, that's not too difficult, right? We've kind of cracked the code on those things. The while loop part is the problem, okay? And in particular, what's the decision that we have to make? Right? We have to decide, okay, the number num is something, right? We have to decide, is that number less than 5 or not? If it is, we continue looping. If it is not, then we quit. How do we tell if a number is less than 5? Okay, we're going to have to do a comparison, but we can't just do that immediately, okay? Because what does the comparison operation that we have do? It compares a register to register 0. Okay, great. But what kind of comparison, what kind of test is it making? It's testing for I can't speak this morning. It's testing for equals or not, right? The stuff that's in a register and the stuff that's in register 0 are either the same or they are not. Yes? Uh, Less than doesn't sound like either of those, does it? Okay, so what do we need to do? We need to recast the idea of something being less than something else in the language that we can do with a equals or not equals kind of question. Okay, so you guys see the issue? Yeah? Okay, so let's come down here. Oops, wrong keyboard. I do this all the time in my other class because I have 3 keyboards up here. Got, 2 laptops plus the Raspberry Pi with a desktop keyboard, and I'm always pressing the wrong one. It sucks. Okay, so let's talk about how can you, what's another way to think about a number being less than another number? Think about that for a moment while I grab a drink. All right, any brilliant epiphanies? Well, I did give you 7 seconds. All right, I'll give you a little more time for your brilliant epiphany. Your brilliant epiphany? Huh? You're not quite, but you said one word that's definitely going to be involved. Yeah. Okay, almost. You're getting a lot warmer. Okay, so you are correct that what we want to do is the number minus 5, or equivalently 5 minus the number. Okay, and bingo, or less than, right? So number is less than 5 means the same thing as the difference number minus 5 is less than 0. Yeah? That's just algebra. Well, if only we had a way to tell whether or not a number was less than 0. Do we have a way to check whether a number is less than 0? We did it last time. Right? Wow, it's almost as if like programming and classes like build on each other, right? Wouldn't that be amazing? Huh? Yeah, that'd be great. Okay, so what we need to do is we need to do to tell whether or not the number is less than 5, we need to recast that decision as checking whether or not the number minus 5 is less than 0. Okay? Um, and how we do that is, well, we do like we did last time. We look at, okay, compute number minus 5, look at that thing, and then we need to look at the far left bit of it. Is it a 1? If so, that means we have a negative number. If it's not, we have a positive number. Okay? Okay, now, um, right, okay. So let's start writing some stuff here, right? All right, so the first thing is we need to load in the numbers 0, 1, and 5 to some registers. Okay, that's good. Okay, so we've got to put them somewhere. So where should we put these? Let's put. Oops. Let's put register 1 with the, well, okay, so I'm going to do this. I'm going to put load, okay, I'm going to do that, right? So why am I putting 0, 0 in, well, actually, you know what? What did we do last time? What did we put in register 0? Okay, so let's in fact go over to it. What did we put in register 0 before? We put 8, 0 in it. Okay, why did we put 8, 0 there? Okay, so what was 8, 0 doing in our program last time? It served 2 roles. Okay, so what was the first role? How do I get the far left bit out of it, out of a number? Yeah, it had to be in a register, okay? But I needed to do a logical operation by anding a number against a 1 in the bit I cared about and the 0 in all the other bits, right? Okay, so I need the bit pattern 8, 0 because that tells me where is the bit I care about and where are the bits I don't care about. Okay, what's the other bit pattern that I haven't put here that we need? Um, well, okay, I didn't do the subtraction in this case, but if I wanted to, well, okay, so let me go back to what we had a minute ago. Okay, do I actually need the number 5 here in my program? What I really need is -5. Okay, um, so how do we compute -5? We did that whole XOR trick. We add 1 to flip the bits, and then we add 1. Could we compute that in advance on paper and just load in what the answer is? That'd probably make things a little easier, right? Yeah. Okay. So on paper, tell me what is -5 with 8 bits and 2's complement? Okay, so figure that out. And then I'm going to replace this here. Okay, so how do you do that? Start with 5, write down 5 in 2's complement, flip the bits, add 1. What do you get? Come on, man, you only gave them like 10 seconds. Yeah, I know, right? Well, let's see what you get. Okay, what is that in hex? Because that's what I have to type.
Okay, so you got F,
Uh-huh, and then,
B.
right. Okay, you can all double check that Owen is correct. FB? Yeah? Okay. That wasn't really a 360 no scope. That was like, that's like you were set up and Dude Bro was slow on his buying round and comes flying out of spawn. Comes flying out of T-spawn 10 seconds after he should have and op to the face. Right? Yeah. Well, CES, but yeah. Okay. So, right. Okay. So I need that. And the reason that I did that part by hand is just because it means that I can do fewer instructions on the machine, and it will save complication in terms of the program. But that's because, like, all right. So what's the downside of doing this? What about if I say, wait a minute, I wanted this to be while num was less than 10? What do I have to do? I have to go back and recompute it. Okay. Whereas if I wrote the program so that it computes the negative of the value, then I don't have to rewrite anything. I just change the 5 to a 10, and that's that. Okay, so you guys see the trade-off here? Yeah. Okay. So, what do we need to do? Okay, so that loaded in the numbers that we need, and what I'm going to do here is I'm going to think of um, okay, so I'm going to put this in register 4, and this will become clear why I'm doing this in a moment. Okay, I've loaded in 1 twice. That may seem silly, okay, but why have I loaded in 1 twice? The reason is I need one of them to be the value of number, okay? The other one is going to be the +1 that I add each time. Okay, so that may seem superfluous right this moment to have 2 copies of the same number, but one of them will change and the other one I won't change. Okay, so this, I'm going to think of this as being, answer, and this one as being num, and this one as being the value 1 to add each time I loop. Okay, so the number num, what are the values that num will take on as this program executes? 1, then 2, then 3, then 4. Okay, which means that I'm going to be changing the value that's in this case register 2 as I go. Well, once I start changing it, I no longer have the number 1 sitting there, but I still need the constant 1 for the addition part there. Okay, so by putting a second copy of it, I have that to go to. Okay, does that kind of make sense? Yeah. Okay, yes and no. Okay, it depends on how we want to do the comparison. Okay, so what does it mean for a number to be less than 0 in terms of its binary encoding? It means that its far left bit is a 1, okay? And so what I've done is the far left bit is a 1, is the bit pattern that's encoded in hex with 80. Okay, so that's the same bit pattern that we used last time. Okay, does that make sense? Yeah. Okay, so good question, right? I need to compare against something, and I can either compare, as we talked about last time, for checking negative, I can either say, is the number negative or not? Or I could say, is it non-negative or not non-negative, which would be negative, right? And we had to make a choice. And the choice you guys made was we'll check whether or not the leading bit is a 1. And that was in hex the number 80. Okay, Gucci or Prada? Yeah, Prada? Nothing. This is maybe a semester or 2 ago. I'd be like, Gucci, and for good, and then we needed something for bad, and somebody suggested Prada. So, well, I mean, the devil wears Prada, so I guess that's bad, right? You guys know that movie? Yeah. Okay. Yeah. Anyway. Okay. So excellent. Huh? You don't know that movie? Oh. Do you have anything you'd like to share with the class? Okay. We're not in elementary school, right? Okay. So, good. Okay, so now to get to work, we have to actually start setting up our loop. Okay, so all of this stuff that we've done so far was just to load in the numbers that we need to actually do something. Okay, but the first thing that we need to do is we need to decide, should we enter the loop or not? Okay, so should we start or continue looping? Okay, and the decision we need to make is whether or not num minus 5 is less than 0. Okay, so we got to start doing that computation. Okay, how do I determine what num minus 5 is? Okay, where is num sitting? Register 2, okay? So I need to do add register 2 and 4 and put them where? We got to put it somewhere. Let's put it, say, in register 5. Okay, so this would be R5 is going to have the value of num minus 5. Okay, but it's really, let me write it this way, num plus negative 5. Okay, is that okay? Okay, so now what I need to do is I need to say, okay, that number is either negative or it isn't, right? So I need to strip out its far left bit. How do I do that? No, not jump, not yet. How do I strip out its far left bit? I need to AND it against the bit pattern, 1 followed by all zeros. Now, do I have that bit pattern in a register available to me? Yes, it's in register 0. Okay, so what I need to do is I need to do AND of registers 5 and 0, and I need to put the answer someplace, so let's say register 6. Okay, so this will strip out the far left bit of that was in register 5. Okay, so what will be in register 6 after that instruction executes? It will be precisely one of the following two things. It will be, okay, 8, 0 in hex, 1 followed by all zeros in binary, or it'll be all zeros. Okay, those are the only two possibilities that could end up there based on how we set this up. That means we now have a basis for a decision. Yes? Okay, so now, Thomas, now what's the next instruction? A jump, okay? And, not hump, sorry. That would be a much more fun instruction, right? Okay, so we need to jump. All right, now the jump instruction uses what? What parts does it have? Okay, what two things do I need to specify? I need to specify a register, and I need to specify a memory address. Okay, good? All right, so what's the register that I'm comparing to register 0? Which one here? Number 6, good, okay? And if the jump takes place, I need to jump to a memory address. Do I know what that memory address is yet? Okay, so where do I need to go? I need to go to, let me call it loop body. Okay, I don't know where that is in memory yet because we're not done writing the program. So let me use the word loop body as a placeholder for the stuff that we jump to. Is that okay? Okay, so if the jump does not take place, what does that mean? Well, not quite halt, but means we skip past the loop body. Okay, so let me call this, say I'll jump to the end of the program, whatever that's going to look like. Okay. All right, now I've left a space there before the comma deliberately. Okay, because here's where we have to start using our thinking cap. Okay, if I don't jump into the loop body, that means I need to skip past it. Okay, and so the jump that I'm about to write on line 25 should, if we get to that line, it should execute no matter what. Okay, so what I need is I need an unconditional jump. a jump that will always take place if I get to that line. How do you think I can make a jump always happen? Exactly. Okay. So this is really sneaky. The jump command requires me to compare register 0 to something, right? What about if I compare register 0 to itself? No matter what's there, it's the same as itself, right? So the jump would take place. Yeah? Is that kind of sneaky? Not really. It's sort of sneaky, but not super sneaky. Okay. All right. So is that okay? Yeah. Ethan, why do you do that? Why do you guys do that weird thing with your green leg and the pant leg cut off? Why do we do anything, right? Kids these days. Okay. So what do we still need to write? We need to write the loop body. And we need to write the end. Okay, and then what I'm going to do, I'm going to put a label in right here, and I'm going to call it check num. Okay, because we have to check whether or not the number is less than 5, right? And that little snippet of code is the 4 lines, or sorry, 2 lines or whatever, right after check num. Okay, now in my final program, do I get to use these labels? No. Okay, but they're placeholders for now to help me kind of, if you'll pardon the pun, assemble the program. Nobody's laughing. You see what I did there, right? No? Assemble? Yeah. Oh, so you followed my instructions? Okay, right. So, do you guys, any of you guys happen to know Adam El-Khalili? No? Anybody swimmers in the group? No, none of you know him? Okay, well, I would, I had him in calculus a year ago, I think. And whenever I would tell one of my real awesome jokes like that, he would be like, ah ha ha, ah ha ha, ah ha, right? In this really sarcastic tone. And it got to be kind of a shtick in class. But okay. All right, so what do we need to do inside the loop body? Well, let's go back up to the Python for a moment. What were the two things that we did inside our loop body? I change answer to be answer plus num, and I add 1 to num. Sound good? Okay, so where is answer sitting? Where did I put him? I put him in register 1. Okay, so if I write answer equals answer plus num, I'm really doing add of what to what to what and putting it where. Okay, so answer equals answer plus num. Where is answer? Where is num? Okay, so I'm adding registers 1 and 2, and I'm putting the answer where? Ah, haha. No, no, no. 1. Because that's where I'm putting the number. Okay, so I'm going to reuse that register. Now, this is, I think, the first time we've done that. Did I ever say that the destination register had to be a different one than one of the source registers? Now, it can be if you wish it to be, but is that required? You guys can't see this. I need to get one of those clear masks so you can see like the giant smirk underneath my face. Oh, they do? Oh, well. We can't have nice things. Or maybe what I just need to do is like build like a plexiglass isolation chamber and like that has like a HEPA filter coming in and out. Yeah, it could be like, well, I don't know, maybe the bubble would fog up too. Yeah. So, okay. So there's no restriction about writing back to a register you started with. Okay, so that operation does, so this does num, or sorry, answer equals answer plus num. Does that bother anybody though, the form of that instruction? Okay, there's a really good reason why I didn't use register 7 there, okay? Because the whole point of a loop is that I don't want to have to rewrite the instructions every time I go through it. Well, if I try to say put something in register 7 this time, what about if I've gone through the loop another 50 times? Well, I'm going to run out of registers. I only have 16 of them, really only 15 because thou shalt not use register 0, right? So you've got to be careful with this. Okay, now I should say, let me go on a tangent for a brief moment. How many registers do we have? 16, right? And 15 if you obey the sort of caveat about being careful with using register 0. How many registers do real architectures have? Well, it depends. How many does the architecture, so Owen's got his iPad there, right, is running an ARM 64-bit architecture. How many registers, general purpose registers, are there? Yeah, and let's get Vanna Runge there to. Mhm. Yeah, that was pretty good, right? How many registers, integer registers, are there? Anybody happen to remember? No, it's 32. Okay, of which a couple are used for specialized purposes. So it's, but basically it's 32. That's a lot. That's luxuriously many. Okay, classic Intel x86 from back in the day and various sort of subsequent tack-ons of it. How many did it have, basically? General purpose ones. 4. The MOS 6502, which powered such advanced machinery as, well, we talked about that, 6502, right? What did it power? 8-bit Nintendo, Atari 2600, Apple II, Commodore 64, the list goes on, right? Also, interestingly enough, how many of you guys have watched Terminator 2? Yeah? The Terminator was powered by a 6502. So, you know, like when the movie's got the, like, from his point of view and there's code and stuff all over the place, that's actually 6502 assembly code. The other famous robot that was powered by the 6502 is Bender from Futurama. So there's an episode where they like X-ray scan him and you see a little chip and it says 6502 on it, and it's hilarious. Yeah, no. Well, you guys can bite my shiny metal, you know what. All right. Okay, so um, the other thing I need to do is I need to add 1 to my number. All right, where is my number sitting? Register 2. Okay, so, and where is the number 1 sitting? Register 3. Okay, so I need to add, oops, 2 and 3 and store that in 2. Okay, so register 2's value will get updated as we do this. But register 3 value will stay at 1, and that's good, so that the next time I loop, I can add 1 again. Okay, so you guys see why I put 2 copies of 1 here now? Yes? One of them is, the first one is the starting value of num, and the other one is the constant plus 1 that I keep adding each time. Okay, so was there anything else to do in the loop body? No. Okay, so what should the final instruction of the loop body be? Go back and recheck. Okay, because what does a loop do? You run through the body of the loop, then you go back and you say, should I keep looping or not? Well, where do we do the check whether or not we should keep looping? We start that at checkDum. Okay, so what I need right here is an unconditional jump to checkNum. Yes? Okay, good question. You could, doing that would be making a do while loop as opposed to a while loop. Okay, and so that's a good question, right? So Python doesn't have a do while. Well, actually, I think it kind of does. But what's the difference between a while loop and a do while loop? Yeah, it runs once before you check whether or not to continue looping, whereas a while loop you check before you do anything. Okay, so it is possible for a while loop to run none, 0 times. Okay, that is not possible for a do while loop. A do while loop runs precisely once before you do any checking. Okay, so because I wrote a while loop in Python to start, I'm going to stick with it. Okay, but no, that's a very good question. All right, so that's it. Then what about the ending routine? Why don't we just print our answer someplace? So let's do store. Where's my answer? It's in register 1. Let me put that in memory cell FF. Just output it to memory, and then what can we do? We can halt. Oops. Okay, so does it look like we have a completed program? Or almost complete? All right, what's the next thing that we have to do? 2 things. We have to turn each of these instructions into a opcodes, right? The sequence of numbers. I also need to get rid of my checknum and loop body labels and end label because those I can't have those for real. Okay, so let me make a copy of this, all that, and let me come down here. Okay, and let's start doing all of that process. Okay, so where is the first instruction is in memory at 0, 0, correct? Okay, what is the opcode for that instruction? What operation am I doing? I'm loading a register with a number, so it should be 2080. That is not what I meant to do. Okay. Okay, is that okay? So what I've written here is the first column is going to be the memory address. The second column is going to be the actual machine instruction. And the third column is going to be the assembly instruction. Okay, and I just have to do this for the rest of them. Okay, so what's the next one? 02 is the memory address. What's the instruction? 2100. Okay, continue. What's the next memory address? 04. What's the instruction? 2201. Right, then what? 06, 2301. Next, 08, 24FB. Okay, what's this address going to be? Careful. 0A. What's the instruction for add? What's the opcode? 5. Oh, and I just realized I should have put add I here. Same thing here and there. Okay, so what's the difference? I put add I for integer addition and add F for float addition, but yeah, okay. All right, so keep going. What's the next one? Oh, sorry, the instruction is, what's the opcode? 5524, right? Okay, now the next one is OC. opcode is, what's and? 8650. You guys buy that? Okay. Next, 0E. All right. What's the jump opcode? B. Which register? 6. What memory address? Where is loop body? I don't know yet. I'll figure that part out in a moment. So let me just put question mark right there, and I'll go back and fill it in. Okay, what about this one? What's after OE? 10. Okay, and this one will be B0. Where does N start? Oh, I don't know that either. So I'll put just a placeholder and check it later. Okay, now this addition is line 12, or sorry, address 12, 5112. Right? Good. Next, 14, 5223, 16, jump, B0 something. Well, where's check num? Where's the first instruction of check num? 0A. So that means that right here, I put 0A. Okay, what about the end instruction? All right, 18. Instruction store would be 31FF. Damn it. Okay, and then 1A would be halt. And what's its instruction? Damn it. Sorry. Okay, so what's the one thing that we haven't done just yet, and then we'll finish? The 2 question marks, okay? So where is the first memory address of loop body? 12. So that means that this needs to be a 12. Where's the first memory address that has the instructions for end? It's at 18. Okay, and now we're basically done. All right, so we'll start. The very first thing next time is actually running this and checking to make sure that it worked and I didn't screw anything up. Okay, Gucci? All right, and reminder that this afternoon, the core skills exam number 3 will be unlocked and available for doing. Okay? All right, see you guys later. Have a good rest of your Wednesday.